Hello students, once again welcome to Bholanath Academy. In this video students we are going to see the questions 19. In question 19 students you have to calculate delta S total entropy. You have to calculate total entropy change and state whether the reaction is spontaneous or non-spontaneous. Okay students, so you have to give the statement whether this reaction which is given here it is spontaneous or non-spontaneous at 25 degrees Celsius. So here the reaction is given students, that is mercury sulfide reacting with oxygen gas and it is forming mercury liquid and sulfur dioxide gas. Data is given students. Here the standard enthalpy change is given of this reaction. This whole reaction we can say it is about system. Okay students, the system enthalpy is given, standard enthalpy is given minus 238.6 kilojoule. By observing the standard enthalpy we can say this reaction is what exothermic reaction because it is what negative. Now students, problem is coming when whether this reaction is spontaneous or non-spontaneous, and you have to calculate, first you have to calculate total entropy, and second time you have to explain whether it is spontaneous or non-spontaneous. Now students, what else is given? Standard entropy of this system is also given. Sometimes they are not written, so you have to understand the entropy. Standard entropy of this reaction is given. So what is you have to calculate students? Since in first you have to calculate total entropy, so students, total entropy you are going to calculate. For calculating the total entropy students, you should know the entropy of the surrounding also. Here the entropy of system is given. Okay students, entropy of system is given. So what is given students? Entropy, standard enthalpy is given. Standard enthalpy change is given, that is minus 238.6 kilojoule. Okay students, it is given to you. You have to calculate what? You are going to calculate total entropy. So standard enthalpy is given students. Now what else is given students? Standard entropy is given of the system. This whole reaction is called as system and it is given to you. It is given to you. How much it is given students? It is given positive, that is plus 36.7 joule per Kelvin. Okay students, so it is given, standard enthalpy is given minus 238.6 kilojoule and standard entropy of the system is given 36.7 joule per Kelvin, and you have to calculate total entropy. Since students, and what else is given students? Temperature is given at 25 degrees Celsius. Temperature which is, you can say, 298 Kelvin. Understanding students? So temperature is given students. So if you want to, since students, total entropy students, formula you are knowing, it is nothing but entropy of the system plus entropy of the surrounding. Okay students, this formula you are knowing students. Total entropy, if you want to calculate, you should know the system entropy plus surrounding entropy. Here system's entropy is given but surrounding entropy is not given, therefore you have to first calculate the surrounding entropy. Surrounding entropy is nothing but negative of entropy of system. Okay students, negative entropy of system is nothing but you have to take the delta standard enthalpy divided by temperature. Okay students, since you know entropy of system is nothing but delta S0 upon T. Okay students, negative of entropy of system will be like this. So students, we will first calculate the surrounding entropy just in equation number 1 and put the value, you will find that you will get the total entropy. Okay students, so first we will calculate the surrounding entropy students. Therefore surrounding entropy is equals to negative of delta S0 upon T. Okay students, just put the value students. Delta H is given, which is given negative minus 238.6 kilojoule. You have to divide with 298 Kelvin. Okay students, when you divide students with the help of the log table, here students minus will go inside, it will become plus. You will get 0.8007 kilojoule and Kelvin will come in numerator, it will be per Kelvin. Okay students, now students, entropy we are every time we are taking in joule per Kelvin. So if you want to convert kilojoule into Kelvin, you have to multiply with 1000. Okay students, same quantity students, if you multiply with 1000 it will convert into joule. Okay students, if you multiply students, this decimal will shift here, it will be 8.07 joule per Kelvin. Okay students, so this is the surrounding entropy students. Now once you know the surrounding entropy students, now put this value, surrounding entropy value, in equation number 1. Put equation 2 in 1, equation number 1. So since students, you know total entropy is equals to system entropy plus entropy of surrounding. Okay students, in this equation when you put students, you will get the value. Therefore students, total entropy is equals to plus 36.7 joule per Kelvin plus now you have got 800.7 joule per Kelvin. Okay students, when you add students, you will get 8037 837.4 joule per Kelvin. Okay students, so this is the value we are getting students. This is the total entropy. Okay students, since total entropy is what, positive 837.4 joule per Kelvin, so this is the total entropy of the system students and surrounding. So your give, since students this value delta S total is greater than 0, therefore you can say the reaction is spontaneous at 25 degrees Celsius. At this temperature students, the reaction will be what, because total entropy is greater than 0 at this temperature, therefore you can say the reaction is spontaneous. Understanding students? So this is the coming for 3 marks question students in examination. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.